Question: Two tractors pull a large rock east through a construction site with a net force of 0 on the rock. Tractor 1 exerts a force of 1.2 multiplied 10 to the power of 4 Newton. The direction is east, 12 degrees toward north on the rock. And tractor 2 exerts a force of 1.2 multiplied 10 to the power of 4 Newton. The direction is east, 12 degrees toward south. A. Calculate the force of friction acting on the rock. B. Discuss two ways someone could support that the force of friction on the rock must be to the west before solving the problem. So we know the net force is 0, and the force of tractor 1 exerts on the rock is 1.2 multiplied 10 to the power of 4 Newton. Direction east, 12 degrees toward north. And the force that tractor 2 exerts on the rock is 1.2 multiplied 10 to the power of 4 Newton. And the direction is east, 12 degrees toward south. So the magnitude of force 1 and force 2 are equal. And A, we need to find the force of friction on the rock. I draw the graph. This direction is north, also positive y direction. And this direction is east, also positive x direction. This dot represents the rock, and this vector represents the force that tractor 1 exerts on the rock, and this angle is 12 degrees. And this vector represents the force that tractor 2 exerts on the rock. This angle is also 12 degrees. And this vector represents the force of friction on the rock. Now I just analyze force 1. So this vector represents force 1. The force that tractor 1 exerts on the rock. This angle is 12 degrees. And this vector represents the x component of F1. And this vector represents the y component of F1, or the vertical component of F1. And this angle is a right angle. So from the graph, we can know that F1x, the force F1's x component, equals F1 multiplied cosine 12 degrees. And the y component of F1, F1y, equals F1 multiplied sine 12 degrees. So this is for the force F1. Now for force F2, this vector represents F2, the force that tractor 2 exerts on the rock. This vector represents F2's x component, F2x. And this vector represents F2's y component, F2y. And this angle is 12 degrees. This angle is a right angle. So from this graph, we can know that F2x, the F2's x component, equals F2 multiplied cosine 12 degrees. And the vertical component of F2, F2y, equals negative F2 multiplied sine 12 degrees. It's negative because its direction is south. It's opposite to the north direction. Also the positive y direction. So here it's negative because its direction is opposite to the positive direction. Now we can get the equation that the x component of the net force equals the x component of F1 plus the x component of F2 plus the x component of the friction. Now we put values in this equation. We know the net force is 0, so its x component is also 0. So the left side is 0. And the right side, F1x is F1 multiplied cosine 12 degree. Plus F2x is F2 multiplied cosine 12 degree. Plus the x component of the friction. And we can get the x component of the friction equals negative F1 multiplied cosine 12 degree plus negative F2 multiplied cosine 12 degree. And this equals negative 1.2 multiplied 10 to the power of 4 multiplied cosine 12 degree plus negative 1.2 multiplied 10 to the power of 4 multiplied cosine 12 degree. And this equals negative 2.35 multiplied 10 to the power of 4 Newton. Here it's negative. It's negative means that its direction is opposite to the positive direction. And then the y component of the net force equals the y component of F1 plus the y component of F2 plus the y component of the friction. Again, the y component of the net force is 0 because the net force is 0. So 0 equals F1y is F1 multiplied sine 12 degree. And F2y is negative F2 multiplied sine 12 degree. Then plus the y component of the friction. We know that the magnitude of F1 and F2 are equal. So at last we can get that the y component of the friction is 0. Now the x component of the friction is this one. And the y component of the friction is 0. So at last we can get that the friction force just is magnitude 2.35 multiplied 10 to the power of 4 Newton. And its direction is west. It's because here it's negative, means that its direction is opposite to the east, positive x direction. So its direction is west. Now question B, it asks us to discuss two ways to spot that the direction of the force of friction on the rock is west. So V1, the reason for V1 is that the direction of the friction force on an object is opposite to the force attempting to move the object. In this question, the two tractors try to pull the rock to east. So the friction of the force is opposite to east. So the direction of the friction force is west. And V2, the reason for V2 is that we watch the FBD for this question and the values for F1 and F2. We can infer that the y components of F1 and F2 cancel each other. So the direction of the sum of F1 and F2 is to the east. And because the net force is 0, so the direction of the friction must be opposite to the sum of F1 and F2. So the direction of the friction must be to the west.